Welcome to part 2 of our 3-part series on improved physics simulation using Python scripting triggered from within the game engine. This is part 2, and once again I must apologize for the echo. We're broadcasting to you live from the Carlsbad Caverns, and so the problem at hand is getting a better, more accurate simulation of these 1,000 boxes that are falling onto our ground plane box. And the problem is that when you go up that high, when you've got that many boxes, it's really taxing on the physics simulation. So to illustrate the problem, I'm going to go up into Blender Game, and from Game we'll select Show Frame and Profile. That's showing you the frame rate, frames per second, and the profile is profiling the different aspects of code. So press P. There you can see physics is taking up 23% of the game. 36, 47, 50, and we're at about 20 frames per second. Things to keep in mind as we go through this. Alright, so this is part 2, and in part 2 we're going to be focusing on the Python scripting aspect. What I found was that basically there is a call that we call physics constraints set num times substeps. And basically by putting in different values, the default value is 1, by putting in higher values, we are going to break up the simulation into smaller steps, and that will give us a more accurate simulation. First of all, in order to work with Python, there's 2 different ways that you can enter things into Blender using Python. This is called the Python console down on bottom, and this up here is a text box, that icon there. And you can run it by running script like this. Now, just to show you some of the differences between these 2 things, notice that down here we've said that built-in modules are all of these things. And so very often in a script you'll see things like import. Import means load up this module that I'm going to use. And the console has already done a bunch of things for you, like for example math-utils, where you find something like vector. Now, quite surprisingly to me, that does not carry through to the text box. So if we try and run script, it will complain. It says, script fail, look in the console for now. Oh, where's the console? Is it up here? No, it took a while to discover that was actually hiding up there, but it's not that. That's not the console, because it says the same thing. Script fail, look in the console for now. Is this the console? Well, they call it the Python console, but not the system console. In order to get the system console, we have to go to Help and toggle System Console. Now there it is. Okay, so let's have a look. And what's the problem? Vector is not defined. So over here we ran this, and we didn't define vector because it's not automatically loaded like it is for the console. Bit of a surprise there. So you have to do something like from math-utils import vector. That'll work. And then if you put this down below, no problem. It will recognize it. However, now we're going to have a problem with this. Let's see what happens when we run it. Run script. We don't even get to the vector, which I promise you would be fine now. But it's giving us an error here. Import physics constraints. We go to Help, find out what the real deal is. And this I've noticed you have to toggle it twice for some reason. Do not press the minimize button, because you can never get the thing back. I don't know why. But you just click somewhere off of the screen to get it to go away. So import error, no module named physics constraints. And down here, import. Capitalization is important. Constraints. Also, not known. It turns out that you can only run physics constraints. It's only available to import it when you are already running in the game engine. So right now we haven't pressed play. We're not started the game engine. It'll say, the console will say entering game engine, and then you can get things like physics constraints. So how do we get this to work? The trick is going to be that we are going to have to use some logic. Alright, so we're going to get into the logic editor, and I'm going to make this a little bit bigger, and make that a little bit bigger. Oh, while we're doing this, maybe I should come down to the bottom here. I've loaded in a neat little add-on called screencast keys. I'll explain how that works later, but basically now when I press the keyboard, you can see what I'm doing over here. It's a very nice little program. Just go and search for 3D viewport screencast keys in Blender, and you'll find it and find out how to install it. So here we are. We have some sensors, and what we're going to do is I'm going to be lazy and attach my sensor to the ground plane, even though I should be doing it to an empty probably. That's probably better style. So add sensor, we're going to use an always because that's what people seem to do when they're doing this. Always gets called every frame. So every frame, no matter what, this is going to be called, and it's going to go into our controller. Our controller is going to be a Python expression, and we have a script. It's already loaded up in the text box, so it's available there. Sometimes you have to go look for it. That's fine. You just have to know where you put it. And normally, this is just a simple, like, pass it along with an and or an or something to the actuator that does the real work. But because Python scripts are so versatile, you can do anything with them. We don't even bother with the third logic brick. So here we are, and basically every time that this frame runs, when it gets to this object that has a sensor attached to it, it's going to say, what should I do with that sensing object? And it says, I'm going to load this custom simulation. We're going to import physics constraints. We don't really need this, so we'll get rid of it. We're going to, well, the number of time steps are already set to 1, so we're going to set it to a higher value, like 4. And we're going to then print some things to make sure that we know that, yes, we actually did all of this. Here's the actual call that does the work. Set num time substeps. All right, so let's shrink this back down. I'm going to make sure that I saved everything, so save there. And now we're ready to run our Python script from within the game engine. We press play, and what we're looking for is less penetration from the boxes. Alright, that looks better. We're still pretty far away, so let's zoom in a bit. And press play again. Yeah, I think that's pretty good now. Have a look at the frame rate. Our frame rate has gone down to about 10, so it's cut in half. And our physics processing time is about 85, so that's more than double what it was before almost. And so that's the cost of good physics. You have to weigh and balance it. You can probably get away with number of time steps being 2 or 3 here. You just want to spend some time playing with it and see what the balance is between accurate simulation and good frame rate, good not chugging the physics engine too badly. So that is a wrap for part 2. In part 3, we'll just tie up some final details and show you how you can bake the animation and export it to an AVI or whatever movie file compression type sort of thing that you can look at it on the web works for you. Thanks for listening. My name is Keston, and this is Improving Physics with Python Scripting.